In early September 2025, astronomers suddenly found themselves tracking an object unlike any they'd seen in years. Catalogued at first as SSW-25b and later named C-2025R2, commonly called SWR2, the visitor is huge, unnervingly bright, and traveling along a path nearly coplanar with the planets. It will appear to pass close to Mars in early October and is slated for a close visual observation by instruments including the Mars Reconnaissance Orbiter. The Discovery SWR2 was flagged on September 12, 2025, by the SSW sensor aboard the SHOW Survey. Within 2 days the sighting was independently confirmed by Australian comet specialist Michael Mattiazzo, who photographed a tail stretching roughly 2.5 degrees across the sky, almost 5 times the apparent diameter of the full moon. Early photometry placed its visual magnitude near 6.2, putting the object on the cusp of naked eye visibility. From the outset, its enormous coma and intense luminosity set it apart from typical comets. Where it came from, and why that matters. Unlike some recent interstellar visitors that appeared from the direction of Sagittarius, SWR2 approached from Aquarius. Its course and timing are notable. It reaches perihelion around the same period as other unusual visitors detected over the past few years. That coincidence, objects arriving on unrelated trajectories but making perihelion within days of one another, has made researchers ask whether random chance fully explains what we're seeing. Orbit and close approaches. Current orbital solutions from public trackers such as Sky Live and JPL Horizons indicate that, as modeled today, SWR2 will not collide with Mars. Its inclination is modest and its perihelion lies roughly 0.5 astronomical units from the Sun. Visually the comet may appear near Mars from Earth, but three-dimensional orbital geometry places them tens of millions of kilometers apart. Forecasts also show a relatively close Earth passage around October 19, 2025, on the order of 0.2 to 0.26 astronomical units, approximately equals 39–39.5 million kilometers. However, those numbers come with substantial uncertainty because SWR2 has only been tracked for a short arc of its journey. Why predictions are uncertain. Newly discovered comets are notoriously hard to predict. As they warm, jets of gas and dust erupt from their surfaces, producing non-gravitational accelerations that subtly but cumulatively alter their paths. SWR2's observation window is short so far, leaving large error bars on its future motion. Depending on the model, the object's aphelion and orbital period estimates range wildly, from a few thousand years to tens of thousands, so astronomers will be refining the orbit for weeks to come. Anomalous composition and behavior. Spectroscopic observations reported by some independent teams have raised eyebrows. Early spectra reportedly show unusually strong signatures of nickel and cobalt, elements not typically dominant in cometary ices. Observers have also described plasma phenomena in the comet's tail that shift color and intensity in ways they argue are atypical for natural comets. A few researchers have suggested the presence of persistent plasma structures that seem to deflect charged particles more strongly than expected, producing localized magnetic disturbances. These claims are contentious and have not been universally confirmed by major agencies. Still, they have fueled a subset of astronomers to ask whether SWR2 is entirely natural. The artificial object hypothesis. Some scientists, notably a research group at Harvard referenced in speculative reports, have proposed a provocative alternative. What if SWR2 is not a conventional comet at all but a constructed object, perhaps a returning mission or probe? Under this hypothesis, SWR2 could house active systems, internal power sources, or propulsion that produce detectable emissions and anomalous plasma behavior. Proponents point to a pattern, a series of increasingly unusual visitors in recent years, each stranger and more structured than the last, suggesting the possibility of systematic activity rather than random debris. A mission, a maintenance run, or something else? One scenario floated by researchers imagines SWR-2 as a long-period maintenance or data retrieval craft with an orbital cycle measured in many thousands of years. In that frame, Mars may be more than a convenient landmark. It could be a waypoint, a data hub, or even the site of caches or installations placed long ago. Historical human activity in and around Mars, dozens of robotic missions over 6 decades, complicates the picture. If an advanced system were cataloging or managing probes, interactions with human hardware might attract attention. Why governments are quiet? When something as unusual as SWR-2 appears, people naturally look to the world's space agencies for clear answers. Yet so far, official statements have been measured, even muted. NASA, ESA, and other agencies have published only the basics: orbital elements, magnitude estimates, and expected sky positions. Beyond that, silence. This careful restraint has fueled suspicion. Independent observers have noted compositional readings that don't match ordinary comets, claims of unusual plasma behavior, and even theories that the object might not be entirely natural. But none of these more dramatic findings have been echoed in official releases. To the public, it looks like a gap is opening. Cautious technical bulletins on one side, alarming speculation on the other. Why hold back? Some argue that scientists simply don't want to overstate early, uncertain data. Others point to policy, the tendency of institutions to keep extraordinary claims quiet until verified beyond doubt. But in a world where information leaks quickly, that very silence breeds conspiracy theories. Researchers outside government programs are already demanding access to the raw data, full spectroscopic files, high-resolution photometry, and telemetry logs that could settle whether SWR-2's oddities are real or artifacts. Until then, speculation fills the void. Possible outcomes. From mundane to dire, what happens next depends on how SWR-2 behaves. Astronomers outline several possibilities, ranging from uneventful to extraordinary. Scenario 1. The simple flyby. The most straightforward outcome is that SWR-2 passes through the inner solar system, never striking any planet, and continues on its immense orbit. If this occurs, it will gradually fade from view over the coming months, leaving behind only datasets, photographs, and unanswered questions. In this version of events, it is simply another, though spectacular, comet, the brightest of a generation but ultimately harmless. Scenario 2. Trajectory shifts. But comets are unpredictable. As they approach the Sun, outgassing jets can act like thrusters, nudging their paths in ways gravity alone cannot explain. If SWR-2 truly has active propulsion, whether natural or artificial, even tiny daily deviations can accumulate into massive changes. A displacement as small as 1,000th of an astronomical unit per day, multiplied over a month, could redirect it toward a completely new encounter. This is the scenario scientists watch most carefully. A slow drift that might alter its relationship with Mars or even bring it closer to Earth. Scenario 3. The unexpected. The most unsettling possibility is some form of direct interaction, not necessarily a collision, but an encounter with human technology, a planetary atmosphere, or even something hidden we have yet to discover. In such a case, SWR-2 could reveal properties no one anticipates. While this remains a very low probability scenario, history shows that the cosmos often surprises us. For now, vigilance is the only defense. Echoes in human history. If the longer orbital models are correct, SWR-2 last swept through the inner solar system roughly 20,000 years ago, at the end of the last ice age. That was a time when glaciers retreated, sea levels rose, and human societies shifted from nomadic to settled life. Some researchers have speculated that ancient myths and monuments preserve memories of unusual celestial visitors from that distant past. Sites like Göbekli Tepe in Turkey, Nabta Playa in Egypt, and even the alignments of the Great Pyramids are often interpreted as cosmic markers. Were our ancestors trying to encode warnings, or to commemorate an extraordinary sight in the skies? Mainstream science urges caution. Correlation does not prove causation. Yet the idea persists because human cultures across the globe have always been shaped by what they saw above them. If SWR2 really is on a cycle of tens of thousands of years, then humanity may be seeing the same spectacle that once startled prehistoric eyes. What this means? Whether SWR2 proves to be an astonishing natural comet or something engineered, its appearance forces us to ask deeper questions. Are the strange visitors we've seen in recent years, Oumuamua in 2017, 3I, Atlas in 2024, and now SWR2 in 2025, truly independent accidents, or do they mark a larger pattern? It also raises a challenge about openness. Should institutions share uncertain data as soon as it's gathered, even if it risks fueling speculation? Or should they wait until conclusions are solid, even if that delay erodes public trust? And perhaps most unsettling, if one day an object like SWR2 does show undeniable signs of artificial design, how should humanity respond? Closing for now, SWR2 drifts silently along its arc. Each night, telescopes from Chile to Hawaii to orbiting platforms refine its position and dissect its light. In the coming weeks, as more data accumulates, astronomers will be able to say with greater certainty what it is, how it moves, and whether it poses any risk. Until then, the world is left suspended between two poles, curiosity and caution. It is easy to let imagination fill the gaps, but the truth will come only through evidence. This story is still unfolding, and the next updates may reshape our understanding entirely. Until then, one thing is certain. The cosmos has not finished surprising us, and SWR2 may be only the beginning.